I'd say, hey, Mr. Myers is here. How you doing? I'm going to be going over simplifying problems involving rational exponents. Okay. So one of the things I need you to know is this rule about rational exponents. So why don't you take this rule down right now? The rule is b to the 1 over n is the nth root of b. All right. So what you're doing is you're going to be basically changing. You're going to be changing the square root or the cube root or the nth root, whatever that root is, and the power inside into an exponent that's a fraction. Alright? So I know some of you say, I don't like dealing with fractions. But these are really, really important for simplifying reasons. So we're going to need to know how to change radicals, radical, into a fraction. Okay? A fraction power. So let's take a look at some examples here. Alright? So let's go, and I've got lots of examples. I'm going to run through these really, really fast, all right? So we're going to write an expression in a radical form. So how do I do that? Well, I'm going to remember this rule that I have here, which is b to the 1 over n is equal to the nth root of b. So all I'm going to do is turn it into it. So if I have a to the 1/6, that's going to be the 6th root of a. And that's it. That's all you do. 6th root of a. Done. All right, let's take a look at another one. Now, this time we have a 3/4. So this is what I'm going to tell you, okay? I'm going to tell you that the denominator is the root and the numerator is the power that's inside the root, okay? And that's what this part means right here, in that p is the numerator and n is the denominator, okay? So we're just going to change that to m to the, what's the root? It's the bottom, right? 4 and 3. Okay? Alright, so let's take a look at the next. That's it, guys. That's the whole thing. Alright? Take a look at the next one. Let's do it again. Now, what we might have to do sometimes is we might have to take care of the exponent by doing some exponent properties. In this case, we're going to have to multiply the 3 and the 2/5. Okay, so let's go ahead and multiply the 3 and the 2/5. And when we do that, we're going to get x to the 6/5, right? Because it's 3 times 2, because 3 over 1, we're going to multiply the fraction. So we're going to multiply the numerator. And then now we're going to convert it into our root. So the 6 is in here, and the 5 is out here. Alright, so that's what we get. Okay, we get the 5th root of x to the 6th. Alright, let's take a look at another one. We got some practice problems mixed in here too, so take some time to look at the practice problems as well. So go ahead and convert this into radical form, dude. Radical. Whoa. I sound like Bill and Ted, right? Okay. 4th power, y to the 4th, with a 7th root. Okay, 7th root. That's it. All there is to it. Alright? Now what if we want to go the other way? Well, if we go the other way, just think about, well, if the root is going to be the denominator, then that's pretty much all we do, right? So we're going to take b, and now it's going to be b to the 1/5. Okay? b to the 1/5, because this root here, that root is the denominator. Alright? What about this one? Ooh, got all kinds of stuff going on here. So check it out. Last time I went over, when we did some things, we did radicals, and we simplified these radicals. And all I said was, you know what you can do is, you can take that 4, and divide it into those powers. So you would say, how many times 4 go into 2? And that would simplify, but normally those powers inside were bigger. Well, they're not bigger this time, but hey, this is what you're going to do. You're just going to take that 4 and you're going to divide it into all those powers that are in there. Now, this works if everything inside is multiplication. If we have an addition or a subtraction, it does not work, okay? So let's take a look here. We're just going to divide 4 into it, all right? So we're going to have 6 to the 1/4, okay, because 1/4 power. X, now we're going to do 2 divided by 4. I'm going to go ahead and put that there, 2 over 4. And then we're going to have y to the 3/4. Now we can simplify 2/4, right? 2/4 is 1/2. So we're going to have 6 to the 1/4, x to the 1/2, and y to the 3/4. Okay, and so this is going to be our answer. All Okay, there we go. Let's look at another one. So this time we have the fifth root of 2x cubed y. So go ahead and practice this one real quick and then I'll go over it. So again, we're just going to have 2 to the 1/5, x to the 3/5, and y to the 1/5. All right, and that's it. That's all you do to it, okay? Change them into rational powers. Change the radical into a rational, dude. Okay, write each radical using rational fraction. 34. Okay, if this is a root, what root is it? It's a square root, right? So it's a 2. So that's to the 1/2. That's it. That's all there is to it. Really doesn't get too much harder, folks. Let's take a look at some other ones. The only way it's going to get harder is if I need to evaluate, okay? What does evaluate mean? Well, what does it mean to evaluate? It means to find the answer. To evaluate this so that we have one single answer, okay? So 32 to the 2/5, that means we're going to take the fifth root of 32 and square it. I recommend you taking the fifth root first and then squaring it. It usually works out a little easier than doing 32 squared, which is a big number, and then taking the fifth root of that, okay? So let's do this. Let's do 32 and take the fifth root of that. Okay, so what we're trying to do here then is we're trying to think what number goes into 32 so that if I multiply it by itself 5 times, you'll get 32. And that answer is 2, okay? Because 2 times 2 times 2 times 2 times 2 is 32. Okay, so the fifth root of 32 is 2. Then I'm going to square it. 2 squared is 4. There's my answer, okay? 4. Alright, so there we go. Let's go on to another one. 49 to the negative 1/2. Now a negative, don't forget that a negative power just brings it down to the bottom. Okay, so we're going to take 49 negative 1/2 and we're just going to bring it down to the bottom, okay? So we're going to have this as 1 over 49 to the 1/2. Now 49 to the 1/2, the 1/2 power is the square root, right? Square root of 49. And what's the square root of 49? 7. Bam. Okay? That's it. Let's take a look at another one. Ooh, man. Mr. Rice, these are big numbers. What do we do? Well, we know that 125 is 5 cubed. So, let's do the cube root. Well, let's bring this down first of all. Okay, this is the cube root of 125. Okay, times the cube root of 125 squared, right? Because the bottom is a cube root, the 2 is a square. So we're going to do the cube root of 125 squared. Now, some of you are saying, but Mr. Myesis, last time you had the square on the inside. Why now do you have the square on the outside? Well, you know what? It doesn't matter where the square goes. It can go outside or like in the parentheses outside like I did here, or it can go inside. Either way works, okay? So we're going to have 1 over the cube root of 25, which is 5. And then we're going to have the cube root of 25, which is 5, and then we're going to square it, okay? So 25 is this, divided by 5, which is going to give us 5. Okay, so that's our answer is 5. All right, let's take a look at another one. 4 over 25 to the negative 1/2. So we're going to use that negative, we're going to flip it, okay? So that's going to be 25 over 4 to the positive 1/2. Okay, that's what happens when we have a negative. We can flip it, make it positive. Now the 1/2 is going to make a square root of 25 and a square root of 4. Then we're going to take the square root of each one, and we get 5 halves. Simple as that, folks. That simple, all right? Some of you are saying, dude, Mr. Reyes, that is not simple. Well, you know, it takes practice, right? Like anything it takes practice. So what's 100 to the negative 1/2? Yeah, some of you figured that out already. It's 1 over 10. Well, you're saying, wait a minute, Mr. Myesis. Slow your roll there. Okay, we're going to do 1 over the square root of 100, right? Square root of 100, because that's a rational power. We get 1/10. Okay, 1/10. So, then they get a little bit more tricky, right? We got, 27 to the 2/3, 9 to the 3/2. So we're going to do cube root of 27. The cube root of 27, because that's the denominator. And we're going to square it. And the square root of 9, and we're going to cube it. So what's the cube root of 27? It's 3. What's the square root of 9? 3. Okay, 3 squared times 3 cubed is 3 to the 5th, which I believe is 2, we'll say it's 3 to the 5th. Can't do it in my head right now for some reason. It's 81 times 3. So 243. Okay, did I do that right? 243? If I did the math right, but you got 3 to the 5th, right? If I didn't do the little calculation part right. Okay. All right, so we got one more, we got a few more here. I'm going to go and let you write these guys down. I'm not going to go over all of them because otherwise this video is going to be forever. So go ahead and practice that one, bring it into class, and then we'll do it in class. And then this one here, it says simplify. So if we're going to simplify, all we're going to do is turn this into its cube root, okay? So that's 1 over the cube root of x squared. So now don't forget that we can't have a root in the denominator, right? So we're going to do cube root of x squared times the cube root of x squared. And we're going to do it in both the top and the bottom. Okay, and so we're going to end up with the cube root of x squared times x squared, so x to the 4th, over x squared. Now that's kind of a silly simplifying, to be honest. I actually like x to the negative 2/3 better because it's more useful when we deal with stuff than this case, okay? So I really don't like that, to be honest. I like the x to the negative 2/3. Alright guys, here's the last one. Simplify that expression. Not that bad. Again, we're multiplying two things, so we're going to add the exponents. So we're going to have y to the 4/5 plus 6/5, okay, because we're adding, or when we're multiplying two things with the same base, we're going to add the exponents, right? So 4/5 plus 6/5 is 10/5, which reduces to y squared. That's it, okay? So there we go, all right? Simplifying problems involving rational exponents. Radical to rational exponents, okay? So we'll catch you later.